Nowadays, the rise and decline of populations are common occurrences already. We get to receive news about how the human population is steadily increasing, while those of the other specific animal populations are getting smaller. In today's video, we will delve into the study that focuses on the reasons behind these occurrences. But before we get into the technicalities, let us first define population. According to Professor Marian Dupo of the University of the Philippines, Los Baños, a population is a set of species that lives together. These populations interact among themselves and with other populations, and observe growth and changes over time. These occurrences are what concerns population dynamics, the study that zooms in on specific factors affecting populations.
In the mind map that we will be presenting to you today, we will be talking about population dynamics and sub-concepts related to it. Under population dynamics, we will first tackle the concepts of demographic factors, population growth, and population regulation. Demographic factors are the elements that signify the entrance and exit of an organism to a specific population. These factors are specifically birth or natality, immigration, emigration, and death or mortality. The first two mentioned factors signify entrance to a population, while the latter two factors are the exit of a population. Birth or natality, as derived from the term itself, is a factor that takes place when an organism is birthed into the population, while immigration occurs when organisms join a population but not through birth. On the other hand, emigration is when an organism chooses to leave the population, while death or mortality is when an organism passes away.
In order to better visualize the growth and decline of a population that is signified by the discussed demographic factors, certain instruments are used, namely life tables, survivorship curves, and age structures. A life table accounts for the rate of natality and mortality occurring in a population during the different life stages they go through, and this is assisted by a survivorship curve, which is the graphical representation of a life table. There are three types of the said curve, namely type 1, 2, and 3. Type 1 curves display a concave graph and represent organisms that usually give birth to small numbers of offspring that they greatly take care of and die at the latter part of their life, like humans. Type 2 curves, on the other hand, are exhibited as a straight line that represents organisms that also give birth to a small number of offspring that they take care of, and a life with an almost equal amount or mortality count on each age interval. Lastly, type 3 curves are convex graph, which signify that the organisms represented give birth to a numerous amount of offspring and rarely survive past their early years. Then, proceeding to the last instrument, age structures are an account of the number of organisms of a population during a specific time period, where the members of the said population are grouped according to their age and sex.
Now, we then proceed to the next subtopic directly under population dynamics, that is, population growth. Under population growth, let us first discuss the concept of biotic potential. Biotic potential aids population growth, for it is the ability of the organisms within the population to reproduce. With this in mind, the concept of population growth rate surfaces. The mentioned concept derives the product of the current population size and the increase in the number of organisms caused by the biotic potential of the population. From here, we can derive certain types of growth patterns, namely, the exponential growth pattern and the logistic or sigmoidal growth pattern. In the first type of growth pattern, its graph exhibits a J-shaped curve. That signifies how the increase in the organism count of a population remains constant despite population growth. On the other hand, a logistic or sigmoidal growth pattern is an S-shaped curve that explains that the increase in the organism count of a population declines as the population growth reaches its maximum. Furthermore, this type of growth pattern is further explained by the fact that given that once a population increases, the resources around them consequently decrease in proportion to the size of the population, which will require the population size to decrease in return.
Lastly, we then get to the discussion of the last sub-concept under population growth, and that is the stages that concern it. Population growth is divided into 4 stages, namely the log phase, the stationary phase, and the death phase. Let us run through this phase one by one. In the log phase, the population is just getting started, meaning that the population size is trivial, while resources are high. As the population enters the log phase, its growth rapidly increases as they also rapidly use resources. However, as time passes by, the population growth comes to a halt and carrying capacity is achieved, which signifies the entry of the population in the stationary phase. Lastly, the population enters the death phase, where decline will happen given that the carrying capacity is now surpassed, which will mean that the population should be decreased in order for resources to be replenished once again.
We are now getting to the other half of the mind map. We then proceed to the concept of population regulation, the last concept under population dynamics. Under population regulation, we will discuss the types of population, the limiting factors of a population, and the concept of ecological footprint. First, we look into the types of population. A population can further be classified into two, semilparous and heteroparous. Semilparous populations are the organisms that possess a single reproductive period and do not exhibit age structures, meaning that they reproduce only once but to numerous offsprings, and are all of the same ages respectively. Examples of this type of population are insects. Then, on the other hand, heteroparous populations are organisms that possess numerous reproductive periods and exhibit age structures. Organisms like mammals are an example of this type of population, given that they have the ability to reproduce numerous times during their lifetime, but only to a small count of offspring and have different ages.
Then, another concept concerning population regulation are the limiting factors, which are classified into density-dependent and density-independent. Density-dependent limiting factors are the elements that occur depending on the density of the population. The factors are mainly biotic and can bring about logistic pattern of growth, where the carrying capacity of a population is affected. Some examples of this kind of factor are the predation and waste accumulation. Meanwhile, on the other hand, density-independent limiting factors do not rely on the density of a population in order for it to occur. These factors are mostly abiotic factors and often cause abrupt changes in the population size due to their nature. With this in mind, the concept of population cycles is also brought about, given that these two types of factors result in changes in population size. Some populations observe cyclical oscillations, where there are constant rises and declines in population size over time.
Lastly, before we wrap up the discussion, we tackle the last concept concerning population regulation, and that is the concept of ecological footprint. The ecological footprint is the area of land and water utilized by populations during their existence, including the production and consumption of resources and the generation of wastes. This concept is enveloped by that of the concept of ecological capacity, which is the general capacity of an area to produce resources for populations. Familiarization with population dynamics and its related concepts will specifically help us conserve diverse and economically essential populations and manage disruptive populations like that of pests. From here on, let us then strive to better understand this study in order to improve in understanding and managing populations.